Hi everyone, this is Bharat and I'm going to present you this presentation on public infrastructure lifecycle management in IoT devices. So what is the misery behind this lifecycle management is that it is not standardized in the IoT industry yet. So people around like in Microsoft or maybe say an AWS, they have customized their own solution. So I was pretty curious about how do they manage, the certificates and public and private key for securing the IoT communication between the device and the cloud. So I have come up with some management kind of protocol where I will present you this scheme. And first, I would like to introduce to public key infrastructure. So what is that? So if let's say if I have a IoT device, I want to communicate with my server with secure links. So how do I communicate? I use encryption. So for encryption, first I use asymmetric encryption in which I have public and private key, right? Everything I will encrypt the data, I will encrypt it with my public key, and whatever the data that is encrypted with the public key can only be opened with the private key. So let's say I am communicating with you and you have two pairs of keys and I have also two pairs of key. What I will do is first I will give my public key to you and you will also give your public key to me. Fine. Now tomorrow if I want to communicate, what I'll do is I will make my data encrypted with your public key so that so that only you can open that data using your private key. The thing is, how can I know that the public key that you provided me in the first place was the correct one? There is where the digital certificates come along, wherein there is a third party authority which authenticates that the public key that you supplied me is actually yours. Okay, so all the public key infrastructure is bound to that. Now, in real time, what happens is that there are some big major companies that are known as root certificate authorities, and these are all the certificates of the root ones are pre-installed with the browser that we use. Okay, and these are all self-signed. So all the browser company and all the OS company all across the world, they embeddedly makes them into their OS update. Okay, so no one can tamper that. But in IoT devices, how do we make sure such kind of life cycle management wherein there is no such OS and at such a small device with very less of RAM, how can you make this whole life cycle very secure? Okay, so I'm going to present you with this model. I hope you will be able to understand it. And before starting this presentation, if you don't know PKI, please search and then continue with this presentation. So what is the major challenge in IoT? And everyone knows is the security thing. So what's the security? First is the availability of the device should be there, integrity that both we are talking it should not be listened by anyone. So the integrity between you and me will be maintained, and everything that you and me are sharing it should be encrypted so that no one can hear and no one can also tamper that thing. If somebody tampers the data between you and me, uh, there must be some mechanism that it should know that the data is tampered. So this is very challenging. Plus, there is some other challenges in the IoT also, wherein I want to authenticate that the IoT device that is accessing my server is actually that IoT device, and on the same side, I want the server that is communicating on my IoT device that is the server is sending some data to my IoT device. Is that server authenticated to send the data. So at that time, IoT device will uh, validate that server. So how do we address this issue? And at the same time, I want my data to be encrypted so that no one knows it, what I'm sending. So the one-stop solution to this two major thing, authentication and the encryption, is digital certificates. So I have digital certificates which plays a major role in IoT devices. Guys, if you don't know what are digital certificates, please please search it. But in a meanwhile, I will tell you in a very short brief. So what does a digital certificate consist of? It consists of your public key, and it consists of an authority that is upper than you, and that is giving you that certificate. And that upper authority is the authority's certificate is being embedded in your operating system that you are using, or it may be embedded in your browser, right? That authority, the root authority, cannot directly give you the certificate, but it will give you through intermediate certificates. And what a digital certificate would consist of is your public key, the issuer, that is the upper root authority, and it would consist of a signature. Now that signature is composed of the private key of your root. Okay, and that verification will be done at my browser end. So I will be able to judge that your certificate is valid in browser. But how do we address this same issue in IoT devices? Well, we store that certificate same way as the browser stores. We store that certificate in the IoT device as well. And digital certificate, we also publish a digital certificate for the IoT device as well. Why? Because IoT device needs to authenticate itself and has to encrypt the data too. So let's get started now with the next slide. So as you can see, how can digital certificates solve the problem? We both will exchange the certificates. IoT device, that is, uh, will basically verify the certificate that the server that is sending that certificate is actually valid, and that certificate that the server is sending is being embedded in the IoT device storage. So it will check that the two certificates would be valid. On the server end, we will authenticate the IoT device certificate, whether that IoT device is authenticated to access this server. Okay. Now, when both the parties are configured with both are okay with their certificates, they agree on a symmetric encryption key, and then they continue with their process of communication. And the process of communication, they may use some other HTTP authorization, like access token things on the HTTP protocol. But what is the major challenge? Still, what is the major challenge? Now, one thing that I didn't told you is that the root authority that is sitting on the top, that is certifying everyone, and whose certificate is being embedded in your browser, is actually giving you a certificate. You means your server that is giving you the certificate for a particular dedicated amount of time. So it has an expiry date on it. So let's say it expires on 2023. So after like maybe 3 years, it would expire. Now, what's the major challenge then? Well, if you see that this IoT device is storing the certificate. Now, if that server certificate is been expired, I have to make sure that the IoT device should have a secured or maybe a new certificate which will going to be registered for that server. Okay. So in my architecture, what I have used is that at the IoT level, I have used self-signed certificates, wherein I have produced some certificates that are not authenticated via any root CA, because that would be computationally hard for the IoT device. Rather, what I have done is that I have stored that certificate on the IoT device. See, this is the certificate. What I'm talking is of the IoT device certificate. Okay, it's the identity. It's like an Aadhaar card for the IoT device. Okay, so this Aadhaar card is with the IoT device as well as with the server. So if tomorrow, if IoT device sends its certificate, the server has the certificate in its storage also. So it will check the two certificates are valid or not. The server will not go to the root CA to check the certificate because it is self-signed by the server itself. Okay, it's the production in the production environment we have set it this IoT device, and we have set the expiry date of this certificate as infinite. Okay, so in RFC, if you go to the engineering task force this thing standards, there is an expiry date for infinity. It's 9999 years. Okay, and what other thing I have done, that self-signed certificates have a major drawback, that it is bound to some security hacks. In a period of 10 to 12 years, it would be able, a hacker would be able to hack it. So rather what I have done is, over the period of time, we change the certificates of the IoT device. Okay, and this will be issued by the IoT device or maybe the server in a periodic fashion. And at the server end, what we have done, server itself has another certificate. Okay, this certificate is nothing but the server's certificate. This is the IoT certificate. Okay, this is the server's certificate. So this certificate is being issued by the root CA or the intermediate CA. Okay, certificate authority, and this is subject to expiry. This certificate is also stored in the IoT device, and as well as the IoT's device certificate is stored in the server. But the server's certificate is something different than the IoT's certificate. This is self-signed, which means that a server before I am deploying it to the industrial site, this the certificate that the IoT device has is already being stored in the server, so it won't authenticate with any third-party uh, services to authenticate the IoT device certificate. On the same hand, the server will hold a certificate which is being authenticated by a root CA that is upper to it. Okay, and tomorrow if I want to authenticate the server's certificate, I have to go to root CA certificate. Okay, but instead what I have done, I have stored the server's certificate in the IoT device as well, because it would be computationally hard for the IoT device to go to the root CA and then the intermediate CA to check the chain of certificates. Okay, rather I have stored it in the IoT device, but this is bound to expiry. The main thing is this. So if there is a renewal process on the server certificate, I have to renew over this also. Otherwise, the IoT device and the server link would be cracked. Okay, so the same thing is mentioned over here. We need to update the server certificate on the IoT device. Otherwise, there would be no communication link which will be established over to the server that is secure. Okay, so I would like to introduce with some kind of industrial technology terminology, that is messaging broker. So what is a messaging broker? In simple terms, what I would say is it's a software buffer. That's it. So it provides a buffer to server and IoT device. So what's the major challenge is that this link, the IoT device and the server link, is prone to failure, maybe some hacking thing or maybe anything, and the server's speed is way higher than the IoT's device speed, so I have to keep a buffer between it. to match up the speed, as well as I want to know at the server end, I want to know all the messages that are being sent to the IoT device. I want to know all that status of that messages that I sent to the IoT device, whether that message has been delivered or not. Okay, if we use direct HTTPS, then it may happen that I send the HTTPS, but it didn't give a response. Okay, maybe due to some battery issues or something. So instead, what I have used a messaging broker. So what messaging broker will do? I will publish a message to a specific IoT device, and the messaging broker will run a loop inside it. Okay, if at all, if it able to communicate with the IoT device, it would send that message directly to it, and on the same hand, it would give the status of that message to be true, that it has been sent to the IoT device. On the same hand, if the IoT device wants to communicate to the server, what it will do, it will uh, first publish it to the messaging broker, and then the messaging broker would send it to the server. So it would create a buffer kind of thing. And the other main advantage of using a messaging queue is that if I want to update all the IoT devices firmware or any kind of thing that I want to update, let's say some certificate, server certificate, then I would make a single request to the messaging broker that, hey, messaging broker, I want to update all the IoT device, and it would, so messaging broker would publish to each IoT device a message. Okay, so it would keep the track of that message also. So it is nothing. It will provide a one-click update invocation call to all the IoT devices which are linked to it. Fine. So I end up this session right now, and in the next video I will continue with the architecture of it, so that we can deeply dive into more into it. Fine.